So not only is this the last video I'm covering in chapter 10 from the book, it's also the last video I'm covering of conic sections. It's also the last video I'm covering of pre-calc V. It's also the last video I'm covering of pre-calculus in general, which makes it the last video of this academic school year, or at least this school year. Okay? And it's going to cover the hyperbola. Hyperbola is not an extreme exaggeration. That's a hyperbole. All right? A hyperbola is going to be a shape that looks like this. Okay? Still have my double helix cone, and I'm dividing it this time going straight down. And as you can see, it gives me two smaller parabolas. And if I was to put those two parabolas on the plane, it would give me something that looks like what's on the right side right here. Now, the only part that's actually the hyperbola, just so I'm clear on saying this, is going to be this. All the other dotted lines that are up here is just going to be material, just going to be items that help me graph this appropriately. Okay? Now, I'm going to be talking about important info. Important stuff. Okay, that I'm going to want listed out to the side at the end of this video whenever you are making this drawing yourself. Of course, I'm going to want the center. Okay? Center is going to be this point that is right here in the middle. I'm going to want the vertices. Vertices is in the same spot that they were whenever we did parabolas, and then they're just going to be the middle of these. These red curved lines are called branches. They're going to be in the middle of these branches. I'm going to want the foci. Foci. Okay. You call it foci. That's what my teacher used to call that. I don't know if it's foci or foci. I'm going to say foci. I'm going to try to. I'm going to want those points labeled. I forgot to circle it. This is right there. I guess that's a blue circle. Not that it matters. One other thing I want on this. Okay. I'm not too worried about the transverse axis, but the transverse axis, you can see where the arrow is pointing right here, is going to be what all of your business is on. It's going to be what your center's on, your vertex, and your focus. I'm not worried about a co-vertex on here. If I did have a co-vertex, it would be here and here, but I'm not going to have you label that because I'm going to jump to the idea of these slant asymptotes. I'm going to want an equation for those. And we'll hit a DHS easy button before the video today where I just give you a formula for putting those in. Because it's going to be easy to draw them. Actually getting a formula for them is going to take a little bit more work, but hopefully we'll have something easy to help us. Now, just like all the rest of my conics that I have been over, this thing does not have to orient going left and right. It can also go up and down. Okay? So, if it looks like, though, what I just had, that was opening left and right, then my equation, this is a very colorful slide. I'm not used to this much colors on my slides. But my equation is going to look like this, where H and K is my center. Good news. A and C, those are still the same as they were with the ellipse. So I don't even have to worry about changing any of that. Now, this is going to change down here. I'm going to rewrite that. I don't like that. So let's use c squared equals a squared plus b squared. So this time it is Pythagorean how my a, b, and c relate to one another. The only thing I'm going to change if it opens in the up and down direction like we see over here is I'm going to I'm going to make it so that the top flip-flops from what it was earlier. So notice, in this case, A does not have to necessarily be bigger than B. Sometimes A will be bigger than B. We'll just say half the time, probably, it's going to be bigger than B. Sometimes it's going to be smaller than B. Sometimes it's going to be equal to B. So the whole A is greater than B thing, boom, it's out the window. Instead, what's going to happen is A is always going to be underneath my first fraction, or underneath my positive fraction, positive rational expression, or whatever you want to call it. A always comes first on bottom, okay? Oh. think we're good. Oh, what's B? We'll talk about B later. Okay. I think you'll see it's very similar to an ellipse. And again, the book has formulas for all these. So if you're a formula-driven person and you just want to plug in formulas and get all the answers, that's fine. I'm going to halfway draw a picture as to what's going on to have it make sense to me. This one just says to identify the vertices and foci, and that's it. It doesn't want an equation. So I'm looking at this, and I still see where the 49's underneath the y, underneath the y squared. So that must mean that, remember, a always has to come first. A has to equal 7. I would go 7 in the y direction. 1, 2, 3. And, oh, it gave me square root of 32. Oh my goodness. So B would have to be the square root of 32. Second. Square root of 32. 5.7-ish. 5.7. And I did fail to mention that I do have, these are going to be y minus 0 and squared and x minus 0. So my center is landing right here at the origin, where it's really nice. There's been some years where that's the only spot it could land, but they've changed it in recent years where it can move around. And so I didn't come down 7 either. 1, 2, 3, 4, 5, 6. I'm getting kind of excited, this being my last video. 5.7 is underneath the x, so I'm skipping around, it feels like a little bit. 2, 3, 4, 5.7. 1, 2, 3, 4, 5.7. Okay, but this doesn't really help me that much. I went ahead and put it on there for later, but really I just need this first one right here because my branches will go off of whatever is first up here. Okay. And so to find my vertices, those aren't going to be hard. 1, 2, 3, 4, 5, 7. So my vertices are going to be at 0, 7, and 0, negative 7. We're about to hit stop on the whole video if I make a few more mistakes. Okay. And the question is, where is the foci? Okay, the foci are still going to land, green. Foci are still going to land somewhere inside these little parabolas, inside these branches. And so to figure out where it's going to be, I'm going to use my c squared equals a squared plus b squared this time. So I apologize, that sign changed from negative to positive when I went from ellipse to hyperbola, but it does. Okay. Now I know what my a squared is, 49. I know what my b squared is, 32. Oh, that came out nice. So C is going to be 9. So it's going to be 9 units away right here and right here from my center. So my foci and inside those branches at 0, 9 and 0, negative 9. So that's all it would want on this. Okay. I think we can go ahead and take it a step further if we've done the last practice problems and write the standard form. Okay. So we'll do this one together. I'm going to let you do the next one on your own. I've got several you're going to do on your own today. I'll, of course, work it out while you have it paused, but just get ready for that. So make sure you're paying attention to these ones that I am talking through. We're doing together. Now this time it says the vertices are at 6, 0, and negative 6, 0. 1, 2, 3, 4, 5, 6. So I already know, since that's the vertices, I know that they are going to open this way. It doesn't really make much sense for them to open any other way. If they opened in towards each other, I would end up getting my ellipse that I had in the last video. So, since they open this way, I know that my x is going to come first. So to recap, it matters which one I have first, whether it's x or y. If it opens over the x-axis, like it does here, it opens in the same direction the x-axis is running, my x variable has to come first. And then my center is going to be halfway between these two marks, 0, 0 right there. So 0, 0, plus or minus, doesn't matter. And then in the x direction, I went 1, 2, 3, 4, 5, 6. So my a would be 6. It still comes over. I'm going to square the 6, and I'm going to end up with 36 down here. Now, it told me some information about the foci, 2 square roots of 10, wherever that is. I'm just going to make up a spot. Should I make up a spot? I'll have the video actually be halfway accurate on it. That's like 6.3. Wow, so we're like right inside right here. It's not where I would have put it, so I'm really glad I did that. But this C being 2 square roots of 10. Did I do 2 square roots of 10? I did. 2 square roots of 10, that's going to help me get my hands on what this b squared is going to be right here. Because remember that c squared, in this case, is going to equal a squared plus b squared. My a squared is 36. My c squared, careful with this, is going to be 2 square roots of 10 squared. Ooh, 2 squared to 10 squared. Some of you are already picking up the calculator. I'm not going to use a calculator. I'm going to square the 2, call that a 4. Square the square root of 10, call that a 10. 4 times 10, let's call it 4. Remember, there's no reason yet, if I'm not graphing, to take this all the way down to b. I could eventually do it, but I want to know what b squared is. B squared is going to equal 4. So if I call this guy right here 36, I would accept this answer right here. Okay, I'm going to give you another one that's centered on the origin. Let's you kind of play with the differences of this. Pay attention as to whether your x comes first or your y comes first. Make sure you get your a in that position that we talked about. And we're going to hit pause on the video, and this one's all yours. We're doing example 3. Just got to make it back to my recorder here. So hit pause. I'll see you guys in a little bit. Let me say again that I'm not really grading your graph on this. If I need to give some partial credit to a graph, I'll be glad to do it. I'm interested in you getting the 4 and the 16 in the right spot with the appropriate x and y correctly above them. Okay. These don't take very long, so I don't mind doing many of them. Let's do one that's not centered on the origin. Okay, let's see how much of a headache this would be. Okay. So wanting the standard form. Again, I like to just come over here and fill in the blanks as I figure stuff out. That always works well for me. Unfortunately, I can't put in my x's and y's yet because I don't know which way it's opening. So the standard form of the hyperbola that has vertices at 0, negative 2, right here, and 6, negative 2. So that right there tells me I'm opening in the same direction that my x goes. The last time it was opening up and down, so the y variable came first. In this case, my x variable has to come first. And the reason that matters is because of this minus sign right here. I want the negative in front of my y variable. Okay. All right, now where are we? So let's find the center. All right, center is going to be halfway between these. We just do half these. Looks like it'd be there. So that's 1, 2, 3, negative 2. Careful on that. 3, negative 2. So it'd be a negative 3 and a positive 2 in my equations. Hey, I got my little distance right here. My a has to equal 3. It went in the x direction, and the a always comes first. So if I square that 3, it gives me a 9. That's good. So I got all that information just from the fact that it told me where those 2 vertices are. The only thing I need now is where this is what this b squared is. And this guy is, remember, foci, it has to do with the c. It doesn't have anything to do with the b. Okay, so I'm going to go ahead and plot these points, negative 2, negative 2, that'd be right here. And then 8, negative 2, right here. And so I can get my distance now that I need for my c. This whole thing right here is going to be c. Okay, so it's going to be 1, 2, 3, 4, 5. So my equation, c squared 25 equals a squared plus b squared. Get my b squared is 16. That's my answer. Again, there's formulas for all this. It'll be on that link that links it to the book. If you're interested in that, I think it's just easier to count and draw a picture. Okay? So this would be full credit. Let's see what happens when we actually graph this. Because as you know, as I showed you at the beginning of this video, there was a lot going on with the graphing. Oh, we're not graphing yet. We're going to do, you're going to do one of these on your own. That's not centered. I forgot that we did this. So you do this one that's not centered, and then we'll come back. I'll work it, and then we'll see if we get the same answer. Okay, so go ahead and hit pause. Here's what I got. The numbers got a little bit hairy on it. I had to scale my graph by 2 in order to get everything to fit on there, so that's why mine looks a little bit closer together than yours. But yeah, nothing too tricky on that other than we're opening in the y direction, so the y came first. In this case, this is a classic example of what I talked about earlier, is that your A is actually going to be less than your B. Your A is 5, your B is 12. And so, as you can see, there's not really any rules that says that this has to be less than, greater than, equal to. It could be anything on it. Okay, so a little bit different than what we had with the ellipse. Now we're going to graph. Before we graph, I want to give you a DHS easy button on how to find the equations of the asymptotes. Okay, so on the transverse, if it's horizontal, then I can just plug in my b over a, and that would be the slope. And then do x minus h plus k. I don't want you to think this is something just crazy I came up with, but this is just my point slope form that I use in Algebra 1. I'm just applying it to this straight line I'm going to have on these hyperbolas. Okay? And the only thing that's going to change is if the transverse is vertical, is I'm just going to flip it. I'm going to do a over b. And again, these will be straight lines. I'll actually show you where this comes from whenever we work an example in just a minute. Okay. Now, in your homework, they're probably going to say, hey, make sure you list out all the important parts, and if it says covertices, put a line through it. I don't want you listing the covertices. The covertices they do not lie on the hyperbola, so I don't really want them on there. Okay, I guess the foci doesn't either, but nor do the asymptotes. But the covertices just kind of get in the way. So I do want the center though. So instead of covertices, maybe I meant to type center right here. Now we looked out on this one. It's going to be centered at 0, 0, right? Same reasons that we had earlier, x minus 0 squared, y minus 0 squared. So I've already got my center right here at 0, 0. We like this, and there will be some like this on your quiz. Okay. Now, just looking at it, remember, A didn't have to be bigger than B, but A has to always come first. And so my A is 12 and my B is 9. And I get to use the same rules that I used earlier where the 12 came out from underneath the x. So I'm going to go 12 in the x direction. I'm going to need to count by 2's again. So I'm going to put a little 2 right there to show that I counted by 2's. And so that's going to be 2, 4, 6, 8, 10, 12. It's going to land me right here. And 2, 4, 6, 8, 10, 12. Right there. Keep in mind I counted by 2's. If I forget, remind me. Okay. B equals 9. That just means I'm going to go up 2, 4, 6, 8, 9. 2, 4, 6, 8, 9. Now, where a lot of people mess up right here is they draw me an ellipse going around these dots. And it would be an ellipse. You're absolutely right, except for I have a minus sign in here this time. And that means I'm going to have a hyperbola. And with that hyperbola, I'm going to have those slant asymptotes that look crazy on there. And so to help me get my slant asymptotes, It's a pretty easy draw on it, but what you're going to do is you're going to draw, instead of an oval through these, you're going to draw an imaginary box. Makes me think of SpongeBob. Imagination. Okay. And so I know it's imaginary. I'm going to show my teacher that it's imaginary by making it so it's a dotted line. It's not part of my hyperbola. And so what I'm going to do now is I'm going to draw my asymptotes. My asymptotes are going to be these imaginary lines that my branches are going to approach. And my asymptotes go through the corner of the boxes and the center of my box, the center of my shape. And so I'm not going to be a big stickler on how wide it is, but I do have a couple rules I want you to follow on it, okay? First up, make sure you're drawing it in the correct spot. I need to know whether these branches go up and down or left and right. So if I go back and look at that screen, whenever the X came first, remember it opens over the X-axis or in the same direction that the X-axis is moving. So my branches are going to go this way. And so what I want to see is I want to see the branch sit on the vertex, as we did earlier, and I want you to approach, not cross, not stay away from, but approach these slant asymptotes that you drew. And that helps to make sure that you drew them at an appropriate width. So I've almost got everything, right? I know what my vertices are. My vertices landed at, what was that, 12? I'll say 6. That's how far I went, but I counted by 2s. 12, 0, and negative 12, 0. My asymptotes, I'm going to have this make sense to you. I'm not going to use my formula on this. Instead, what I have is I have this blue line right here that's going through the origin, so it's at 0, and it's a straight line that rose 9 units and ran 12 units. So the rise over run would be 9 over 12. And then the one that's running this way, that's going this way, is a negative. I'm rising 9. I'm running negative 12. And so my asymptote is simply going to be y equals plus or minus 3/4 x on that. You know, you're saying, well, where'd your h and k go? Remember, h and k are my centers, so I'm just adding 0 to it. And so that would be it. And that should match up with what I had for the a and the b, or the b over a, whichever way this one fell. I am missing those foci on here. Okay, so I'm going to come up here and do my little bit of math to find my foci. Remember, it's going to be a squared plus b squared. And so 144 plus 81. It's the third video I've made today. I've made all the conic section videos today, so I'm not going to try anything funny in my head and mess something up at this point. And so, yeah, C does equal 15. Remember, the foci are going to land inside each branch. So 12, 14, 15. Give me a big dot right there. Put a little F by it. Mark it with an X. I don't care. I just need to see something out here that says where the foci are. So the foci landed at positive and negative 15 and 0. A lot going on there, but I'm checking all that. So make sure you get each one. Obviously, the quiz can't be as long as it normally is to make sure we get all this stuff in, but label everything that's important. Okay. I'll do one more with you, and I'm going to turn you loose on the last one. Let's do one that's not centered right there. That's going to make it so the isotope's a little bit harder to figure out. Okay, so I'm going to go back to my formula that I put on that one slide to figure out what the isotope will end up being on this one. So, it's already in standard form. I appreciate that, because that's going to change in just a minute. And the center is going to be at 3, negative 4. I've changed both of them. Remember that the h comes with the x, the k comes with the y. So 3, 1, 2, 3, 1, 2, 3, 4, negative 4. Landed right there. And I just start working this one like it was an ellipse. I'm going to go 10 in the y direction. My a is 10. And so if I count 10 in the y direction, that's going to be 1, 2, 3, 4, 5, 6, 7. I should have counted by twos again. Let's see if I can count by twos. That would have been a good note to self before I started all this. So, starting all over, 3, negative 4. Now I'm here, counting 10 in each direction. That'd be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I can get those points later. And then my b is equal to 8. Again, does a have any bigger than b? So I'm going to go 8 in the x direction. 1, 2, 3, 4. So I'm counting by twos. 1, 2, 3, 4. And guys, that's going to be enough to draw your imaginary box. The house that lives right there. It's time to go home. And then that imaginary box is going to be enough to draw your asymptotes. Remember, the asymptotes will go through the corners and through the center. Okay? And that's going to help make sure my branches stay skinny enough, wide enough, whatever I'm wanting. So think about which way you're gonna draw your branches. Are you gonna draw them so they open up horizontally, or are you gonna draw your branches so they open vertically? You should draw them to open vertically. And you got a pretty good drawing up there, except for the fact that you don't have your foci. Let's go ahead and do that one first. Okay, so it's just going to be 100 plus 64. C equals the square root of 164. That doesn't really help me a lot, that square root of 164. So I'm going to hit second square root 164 and get that as a decimal. And I'm going to be 12.8 units away from the center. So how far was this? 10. So 12.8 would be about right there. 10 to 12.8, about right there. Okay, now listing out all of your important stuff is going to be a little bit harder this time. So I've got my vertices. I'm going to do first. My vertices were those green dots that I did that my branches are sitting on. And keep in mind I counted by 2, so it's going to be at 3, 1, 2, 3, 6, I believe. And it's going to be at 3, let's see, 2, 4, 6, 8, 14. Negative 14. That looks weird. All right, what else is important on here? The foci. Those are going to be important. Put those on here in black. They're still at 3 something. So, I don't know why I made that so big. We'll work with them. So I'm at 3, and then remember I counted up from there. So I went 2, 4, 6, 8.8. Just a little bit bigger than that, almost halfway. And then I'm at 3, and I went, let's see, this was at what, 14? 1, 2, 3, 4, 5, 6, 7. And then 14, 16. So kind of weird to get your hands on that. Keep this 0.8 in mind whenever you're counting, going away from the center. Okay. And last up, I have the asymptotes. The asymptotes. I also did in black. Again, I don't think it's going to be hard to get your hands on the slope of it. I can definitely from this point right here do a rise over run to get my hands on the slope. However, to get my hands on the y-intercept on this one, you can see that the y-intercept is going to be different for both of these. One, it's way down here, if I even drew it accurately. And the other one, the y-intercept, man, it looks pretty close to 0, 0. And it very well could be. But that's just a lot of work to do on it, okay? Every time, let me get those off. Every time it's going to follow my my equation that I gave you earlier. Now in this case, my transverse axis is running vertical. Look at your vertices, look at your foci, look at your center. They're all lying on a vertical transverse. And so if that's the case, my formula I'm wanting to use is A over B times x minus h plus k. So if I plug in what I know on this, my asymptotes are going to be A over B. Well, we said A was 10, B was 8. A over B would be 10 over 8. Reduced would be 5 over 4. X minus h, my h is 3, plus k. My k is negative 4. And that would be the equation. I could find each asymptote by just simplifying this equation. I don't have to. You can just leave it like that. Okay. I'm going to let you play with this one. As you can see, I've got to do what I did on the last problem on the previous video. I've got to do the whole completing the square thing. And so I'm just going to make the video way too long if I work this one out. So I'm going to go ahead and hit pause. I'm going to attempt this. I haven't worked this ahead of time or anything, so if I make a mistake on it, no big deal, but go ahead and hit pause, work it out, I'll work it out, and then you can check your answer. This one was a doozy. If you didn't get exactly this, pause the video, see where you went wrong, work a different one. There should be one similar to this in your practice problems. Biggest mistake I remember people making on this one was right here, I had to pull out a negative 4. And so whenever I pull out a negative 4 from this negative 40, it turns to a positive 10, making it so that I have a positive, I end up with a negative 5, I guess, on my center down here, because that's positive 5. So careful with that. Check over my work, make sure it all looks good. If I made a mistake, shoot me an email, let me know. And I can definitely try to fix it. But I feel pretty good with it, worked it pretty slow, and anyway. Last assignment I want to give is this one. They're not all long like this last one. Some of them are just simplifying equations. You got to be able to do both of them though. So if you have questions on some of these, let me know. Put a big star by it, and we can work them out together. Have a good day, and I'll catch you guys later.